So 5 goes into 25 5 times, and that's going to be over the square root of 3. Of course, we usually want to rationalize the denominator. So we're going to multiply the denominator times the square root of 3, the numerator times the square root of 3, and this should all simplify down now to square root of 3 times square root of 3 is 3, and we have 5 times the square root of 3 on top. So there you go. So y is equal to, let me just go ahead and rewrite that because that looks like a mess. Actually, you know what? I'm going to go ahead and write my two positive numbers. We'll just write them right here. How's that? So our x was 5 times the square root of 3, right? 5, and of course these are exact values. We don't want to approximate. And then our second number, or our y, is 5 square roots of 3 over 3. So these are our two positive numbers, right? And you can go ahead and plug those in a calculator and get an approximation if you would like. But so anyway, just recapping real quick, we wanted two positive numbers, and we set our variables up. Just let one be x and the other be y. We set up our primary equation. Okay, this is the one we're going to always take the derivative of, set it equal to 0, and solve for x, or solve for y, or solve for whatever the name of your variable is. Then we had our secondary equation here, and we got everything in terms of one variable. That was the whole idea. We solved for either x or y. It doesn't matter which one. You can solve for x in this problem, solve for y. This could be x is equal to 25 over y. It's all going to work out the same in the end. All right. Then we take that, we take our primary equation. We want to get everything in terms of one variable here, and take the, usually, you know, well, in this case we got to rewrite, take the derivative, set it equal to 0, solve for x, and right, once we solve for x, we go back up and solve for y. Now, of course, you know, there's some steps here that I'm actually skipping. In the under this applications of the derivative, when we were doing our first optimization problems, we found what are known as critical numbers. Okay, then remember we drew a graph. We did this, so this was like critical number. We'd put 5 square roots of 3 here, and then we would test, take a test point to the left, a test point to the right, and of course in this particular case the graph should be doing this, since this is a minimum occurring here, and then a plus here and increasing. These were some of the ways that we tested for min-maxes in some previous sections, and if you've probably forgot that, you might want to go back and review those things. But I'm kind of skipping this spot, and I'm bringing actually up the graph so we can kind of look at the graph and go from there. But this kind of proves that it's actually a minimum here, and of course, you know, I guess that's important. But anyway, I'm going to assume kind of that you know that already. And basically what we're focusing on are these guys here, and getting everything in terms of one variable and taking the derivative and so forth. All right. Well, let's move on to some more problems.